Welcome back to the Ocean of Chaos. It's been a while since I posted something. I figured I'd give everybody an update as to what's been going on in the world of the feral engineer. Thank you guys for following me. Thank you for subscribing. I do appreciate it. I think I have I don't know 28 followers at the moment. So thank you guys. I do appreciate it. You are the OGs. So quick update as to what's been going on between my little tool reviews and whatnot. Since then, what have I done since then? Since the tool reviews that I've been putting up, I bought a second house and I've been working on renovating that to flip it. I built a little side deck on my house proper, and then a couple other things here and there. The home renovation I've been keeping tabs on through my Instagram page. If you want to follow me there on Instagram, I am Body by Boston Cream. It's all one word, so Body by Boston Cream. You'll see me. So getting back into the ocean here. Recently, with this COVID-19 thing, everybody's been locked indoors, so I've been finding time to catch up on some old projects. I finished a guitar I was making. I do build guitars, by the way, and I'll be posting some videos on those as well. Along with that, I've been updating my CNC machine. So I got this CNC router about 10 years ago. It's kind of like, this is why it's the Ocean of Chaos. I bought this 10 years ago from a company that sells kits. It wasn't CNC router parts. It was a company that was basically a CNC router parts reseller. They would sell their own extrusion designs, and then they would have, the 80/20 extrusion drop ship from 80/20, and they would have all the other stuff drop shipped directly from CNC router parts. So really the only thing that the guy was doing in between was drawing up some rails in SolidWorks, which I don't even know if he was doing that, to be honest with you. I won't divulge the company name because I find that the owner of the company is very unprofessional, doesn't answer emails, and I've been dealing with him on and off for the last 10 years. I've had a coworker buy a machine off of him last year, and the same story. He doesn't answer emails, he doesn't get back to anybody. And anybody that's in the CNC router industry, anybody who's done these kit builds, they know who I'm talking about, and I'm not going to get too deep into it. Anyway, so this machine came from the reseller, what have you, came with a rack and pinion on what is my X, because the way I look at machines, X is my long travel, Y is my short travel, and then Z is my normal travel. My X is rack and pinion. My Y was lead screw drive with anti-backlash nut and whatnot. My Z-axis is still lead screw, 5-star Acme thread with anti-backlash nut. But I found that no matter what I did, and I think it may be part of just the floor that it's on. I don't have leveling pads underneath it or whatever. But the machine, ever since it's been in the corner over here, it's always had a weird vibration in the lead screw. And longer lead screws, you can attribute it to screw whip in the middle, and it did seem to be worse in the middle. So I need anywhere between like here and here, give or take. Anything over 60 inches a minute, and this thing would just go woo, woo, woo. It was terrible, and it would, the resulting finish, even in a piece of wood, would be very, very poor. So given the situation with this COVID crap, everybody is, I am especially, I'm working from home for the most part. So I've had a chance to catch up on some loose ends. And one of them being to make my machine a little bit better. So what I did was, knowing that the rack and pinion drive system and all of the bearing trucks and whatnot were distributed through CNC router parts, I went and ordered another rack and pinion drive system. So with this rack and pinion drive system, I eliminate the lead screw thereby eliminating the anti-backlash nut and the whipping in between. So with anti-backlash nuts, you can still have backlash in the nut. And in my case, the O-rings that were holding the anti-backlash nut tight had broken. Um, so the option was buy a 10-cent O-ring or spend 200 and something bucks and upgrade to a rack and pinion system. I do like the rack and pinion system. Theoretically, it's not as accurate, so to speak, but I mean, think about where it's coming from. I'm working with a steel plate for my bearing system, for my weigh system, and I'm running stepper motors in an open loop system. So how accurate is it going to be? It'll be repeatable, yes, but it's not CNC level like the company I work for accurate. This is for woodworking. It's woodworking, plastic, things like that. You're not holding gajillions, or as I always say, you're not splitting atoms. So what I had to do was I installed this rack and pinion system. In order to do it, I had to order the extended bearing carrier for the upper rail, which was fine. I kept the lower as a standard size only because I didn't want to spend another $40 or whatever on this, knowing that the torsional rigidity isn't going to be any different, and it's just ball bearings that are carrying the bottom portion of the Z, so no big deal. So I went with the extended bearing carrier. I got the rack and pinion drive system, and then I got the Pro Rack because the company that I bought from had a rack system with countersunk holes, which would bolt directly in, right through here, boom, into the extrusion. And the standard rack through CNC router parts was like $40. Plus, you had to order their hold down system, which didn't use the screws, it used these little hold downs. So you'd have to put a hold down and then on top of the rack system. And you have to get a bunch of them. So altogether, the cost difference between the Pro rack and pinion and the standard rack and pinion was a couple of bucks. It wasn't that much, it wasn't that expensive. So I said, screw it, I'll go with the Pro rack system. I ordered the nuts and screws that hold it all down, so I had to pay the extra $7 for all the nuts and screws. And if you price the stuff out, it's pretty much a wash. So it's no big deal. So with the extended bearing carrier and rack and pinion system, I then had to figure out a way to reroute my cable chain, because my cable chain was originally in this area here. So against the plate, I had the cable chain bolted in here, and it would run that way. It would run that way, around, and then back, and then down and across. So what I did was I had to figure out a method to run the cable chain after the rack and pinion got put in place. And what I chose to do was, for $6, I went to Lowe's and I picked up a piece of steel channel, which is located over by where they keep framing 2x4s and whatnot. It's like one or two aisles from where they keep framing 2x4s. It's steel framing for buildings. There's two different types. There's the stud and then there's the channel. And the channel worked out better because it didn't have a lip, and the stud actually had a lip that folded in, and that wouldn't have worked. But I picked up the steel channel. It's about 3.5 inches wide, 1.25 inches tall, and you can get a 10-foot length for $6. So I cut the piece that I needed for my Y. I didn't get the cable chain yet. That's coming tomorrow. And then on my X, I did the same thing. I did a full length cable channel. Cable chain just sits right inside of it. And then when it goes to full extension, the cable chain will just follow along with it. So that's all working out pretty well. So anybody looking to change their older or standard, even CNC router part machine, if you're using lead screws, as long as you're using these bearing blocks, you can use the rack and pinion drive system, and it just bolts in with one bolt here. It's a shoulder bolt with a washer that keeps everything elevated so that it can move freely. And then there's this this spring tensioner system here that requires the extended carriage, just because you need a provision for the bolt there and you need the provision for the bolt there. The standard bearing carrier doesn't include that. So all in all, it's working out pretty well. And then this piece of threaded rod, in case you're wondering, what I'm doing with that is the way that the cable chain is going to route now, it's going to go towards the wall. It's going to be opposite to what it was. And I'm going to connect the chain here. And then around with my Z. My Z doesn't move, but I'm going to run cable chain so that I can get my stepper cable and my spindle cable through the chain, which will keep it positioned a little bit better than what I had. I had it running up into the ceiling on this piece of duct support, and you can see that that's seen better days. But I'm going to run around. This will come down and essentially screw onto here. I'm going to drill a hole into the cable chain and just put a nut and a washer on both sides. And then from there, it'll route into this chain. And I think it'll be good. It'll keep all the slack away from getting into danger and whatnot. And we'll have winter chicken dinner. So again, it's a very simple conversion as long as you are using that type of bearing carrier. If you are using a different weigh system or carriage system, then you'd have to do a little bit of monkey work with it, but all in all, it worked out pretty well. The one thing that I do want to point out, that this plate was originally, you can see it's a little asymmetrical. This plate was symmetrical like this one here, but this plate is 4 inches wide, and this plate was designed to use a rack and pinion system. This plate was 6. And in order to have the proper setback for the rack and pinion to sit, the plate has to be a 1/2 inch overhang from the extrusion to the top of the plate. I had 1.5 inches, so I had to call in a favor and have that plate milled down 1 inch. I did it 1 inch, and I didn't do it on the other side, again, for torsional rigidity, because the smaller you get, the less of a span you have between the support blocks, and the more tendency you'll have to do this for, torsional deflection. So I opted to keep the 1 inch under, or the 1.5 inch underneath, and a 1/2 inch overhang here, and then everything went together perfectly. So just be aware of that. If you have a 6 inch guide plate and you want to go rack and pinion and you only have a 3x3 extrusion, then you'll have to get your plate machine down or buy a new plate, whichever one is less expensive. I do plan on eventually either upgrading to a different machine or figuring out a way through extrusion and bracketry and whatnot to convert this machine to linear guide rails. But that's for a whole nother video. So if anybody has any questions about this conversion, just let me know in the comments and I will get back to you. Thanks for watching.